Hello, this is Stefano Pescosolido, Microsoft Technical Specialist for Cybersecurity Solutions. What I'm going to show you today is a demo about Defender for Containers in a multi-cloud environment. Defender for Containers is a plan in Microsoft Defender for Clouds, which is aimed to protect Kubernetes clusters and their running workloads. Specifically, it's able to detect misconfiguration and somehow also to avoid them, so to block possible misconfigurations in terms of security. It's able to detect vulnerabilities on images on Azure container registries, and in running containers in AKS. It's able to detect possible threats on running clusters and running workloads. And it's available for Kubernetes clusters running in multi-cloud environments. So for Kubernetes clusters running as standard CNCF clusters in on-premises data centers, as well as in cloud providers environments like Azure, AWS, GCP, or Kubernetes clusters running in as managed platform as a service clusters like AKS for Azure, EKS for AWS, and GKE for GCP. Defender for Containers offers also the possibility to easily provision the solution also to new cluster deployed on those environments, and it supports standard monitoring tools for Kubernetes. The alerts detected by Defender for Containers can be mapped to the tactics and techniques in the MITRE metrics for Kubernetes. So we see here some of those possible threats that can be detected by the product on different clusters. The components that realize the solutions are different depending on the type of clusters. In this diagram here, we see the example in a standard CNCF Kubernetes clusters. Basically, we have the workloads for having the clusters mapped in Azure Arc, so visible in the Azure Arc control plane in Azure. The components, the workloads that protects the different nodes and the running workload on the clusters are realized as a daemon set. So they are automatically deployed on each node of the Kubernetes cluster. Another workload is the one which realized Azure policy extension. So the capability to connect Azure policy with the gatekeeper on the Kubernetes clusters. In EKS and GKE, there is a different mechanism for the Kubernetes audit collection, depending on the fact that the control plane in that case is managed by the cloud provider. In AKS, not only that component is different, specifically in this case is native, but it is also evident the fact that there is no need of having Arc-related workloads because AKS is running inside Azure. Moreover, the Azure policy is connected through an add-on for the cluster, not as an extension. In my lab, I have created an AKS cluster, a GKE cluster with 3 nodes, and an EKS cluster with 1 worker node. And finally, a standard CNCF cluster, which is hosted in the Google Cloud Platform. Obviously, in order to test the Defender for Containers detection capabilities, as first action, I needed to ensure that those external clusters were visible in Azure Arc as Kubernetes-enabled clusters. So I needed to manually onboard the AKS cluster in Azure Arc. As well, the same I did the same for the standard CNCF Kubernetes clusters, while for the GKE cluster, I leveraged the automatic provision which is offered by Defender for Cloud. More on that later in the demo. In order to test the detection capability of Defender for Containers, I used this nice project named Kubernetes GOT, realized by Madhu Akula, a DevOps security expert. This is published in the pages linked here and that you can see here. And I also found very interesting blog post written by Guillaume Benat, a colleague, a cloud solution architect in Microsoft specialized in security. It describes in details and very clearly what are the detection capabilities for Defender for Containers. So I recommend reading that blog post too. Last point before starting the demo, I took all the images realized by Madhu Akula in the Kubernetes GOT project, and I brought it in my container registry in Azure. I did this because I wanted also to test the vulnerabilities detection capability in Defender for Containers. Okay, it's time for starting the demo now. Let me begin with this evidence. I want to show you quickly some of the components that are deployed in the different clusters by Defender for Containers. In order to enable Defender for Containers, here we are in the GKE cluster. We see that there are different namespaces. Specifically, there is a namespace for Azure Arc containing all the deployments, so the pods that are needed to have the GKE cluster mapped in Azure Arc. We have another namespace which is named Azure Defender. It contains a couple of deployments related to Defender for Containers, as well as the two daemon set which are needed to have the solution, the Defender extension in all the running nodes, worker nodes. Some of the components of the solutions are within the Kube system, so in the system namespace for the cluster. We see it by the name, so Azure Policy Webhook, for example. Those are related to the Azure Policy integration with the Gatekeeper. Same here in AWS. What we see, for example, here we can see the two daemon set which are deployed in the cluster, so which ensure the Defender extension running in all the worker nodes. Same for the other kind of workloads. Instead, considering the standard CNCF cluster running in GCP, here I have a cluster with 3 nodes, but in order to see which components have been deployed, I have to use, for example, an SSH connection. So, for example, I get all the daemon set running in all namespace, and I see that there are the 2 daemon sets which we saw earlier in the other clusters. Of course, we can see the workloads of the external Kubernetes clusters also looking at the Arc control plane. So in their projection in Arc, for example, this is the projection of my standard Kubernetes cluster running in the GCP environment. Okay, so here we see the workloads available. And again, we can differentiate, we can filter by namespace, and we see the same namespaces which we saw directly in the different clusters. So the one for Azure Arc as the one, for example, for MDC related to Defender for cloud. The situation is not very different in my AKS cluster running in Azure. Here again, we have some of the components which are realized the Defender for Containers solution. We see those from the names. Of course, we do not have component related to Arc because AKS is already running in Azure, so there is no need to have Arc there. We see some little difference related to internal implementation. Just as an example, Defender for Containers daemon set is running within the system, the cube system namespace. And another difference is related to the integration with Azure policies. We see that here in AKS, this is realized through an add-on, while we know that in the external clusters, like this one, the standard one, it's realized as an extension. So we have the running extension as we have the running extension related to Defender installed in each cluster. Okay, so now it's time to move to Defender for Cloud. Here we are in the home page of the Defender for Cloud part in Azure portal, and the first point that I'd like to show you is how to configure the Kubernetes protection. So going in the subscription in Azure, I can the first action that I have to do is to enable the Defender for Containers plan, which basically means to tag on these settings here. I have also the possibility to specify advanced configuration related to the deployment of the daemon set in the cluster, the one that ensures the existence of the Defender extension in all the running worker nodes and the running nodes for standard clusters in general, and the possibility to deploy automatically the Azure policy for Kubernetes. So the extension for gatekeepers that we saw earlier, which is deployed as an add-on, an add-in for AKS in Azure, and as an extension for Arc clusters. Okay, this is in Azure, but if we want to configure the protection also for EKS in AWS, we have to enable the containers plan here at the configuration level for the AWS account. Here we have another setting available, which is the possibility to specify if we want to collect audit logs and which should be the retention, the audit logs related to the Kubernetes, EKS Kubernetes cluster. Well, if we go to the GCP project containing a GKE cluster, if we move to the plans, we see that we have also here a specific plan to enable for the protecting the GKE cluster. In this case, of course, we have to put it on, and we have different settings available. Specifically, the one very interesting is the capability to auto-provision the extension for Azure Arc. That's why when I set up my lab, I did not needed to manually install that extension. It was automatically installed by the platform. And again, I have the possibility to collect audit logs, and I have the possibility to auto-provision through Azure Arc the extension for Azure policy. This is related to how to provision the solution. Now, let's go to see what we have in Defender for Containers. In my lab, I want to show you what was detected by Defender for Containers. First things I do is I filter out the other kind of resources, and I just concentrate on Kubernetes services, which is AKS, Kubernetes Arc, containers, Azure Container Registry, GCP Containers Cluster, and EKS, sorry, which is named in this way. So I needed to specify in this way. Okay, here we have the inventory of all the Kubernetes clusters in my lab. What I can show you here is that I have an immediate evidence of all the status of the recommendations related to Kubernetes in all these clusters. It's a graphical representation that gives me a clear evidence of what is the status. Here we have two clusters which are not covered because they are autopilot clusters in GKE. Okay, if I select one of those clusters, for example, the standard one, I get a first tab with all the details related to the recommendations. So I get the full list of all the recommendations that were identified for my standard clusters. And for each recommendation, I see if the status, if it's healthy or unhealthy. So if the clusters respect that recommendation or not. And the number of components which have been identified, so which are not healthy for that specific recommendation, the number and the kind of component. In this alerts tab, I see all the alerts that were raised for that specific resource, in this case, my standard cluster. In my lab, I did a lot of simulated attacks to the components deployed through the Kubernetes Goat project. The Kubernetes Goat project contains a set of vulnerable containers and related resources. They are done this way to be vulnerable just because it's kind of instructive to see how they can be those vulnerabilities can be exploited and how products like Defender for Containers can detect this kind of attacks. So that's exactly what I did. This is the inventory, but here in the recommendations page, I can get all the recommendation aggregated, not so specifically for a single resource, but aggregated. In this tab, I see the recommendations which are concurring to the evaluation of the secure score, which is this kind of global score assigned to all the resources protected by Defender for Cloud. Here in the all recommendations page, I see a flat list of recommendations, while in that secure score page they were grouped. Here they are flat, and in this page we have also recommendations not concurring to the secure score assignment. So we have basically all the recommendations available. Again, here I have to filter to see only my Kubernetes resources. So I get, again, Kubernetes, I get Container Registry, GCP, and EKS. Yes, my lab is quite full of resources. So finally, I get this list, and the recommendations are obviously classified by severity. Defender for Cloud now has a management capability, so the recommendations can be assigned, and we have the status column which tracks the status of the solution of the recommendation. So if they were somehow completed, or if they are unassigned, if the assignment has been done and the solution is on track. So this is kind of a management of the assignment. Interesting here is the status the overall status of the recommendations. So we see graphically and by number each recommendation, how many resources, for each recommendations, how many resources are affected. The kind of resources, of course, is also shown. Very interesting is this column related to named insight, because it contains these symbols, which gives me an overview of what I can expect to have in that specific recommendation. So here, this kind of symbol represents the fact that the recommendation can be applied also in deny mode. When a recommendation is applied in deny mode, the creation of the deployment of new resources have to respect that recommendation. Otherwise, the deployment of new resources is blocked. So it's not possible to create new resources which do not respect that specific recommendation. Otherwise, if it's not deny mode, it's audit mode. I just get the evidence that there is the recommendation is not respected. Here we see this different symbol, which shows that for the recommendation there is a fixed solution. So if the recommendation applies to an Azure hosted service, the fixed solution basically is most of the time is just a button. When pushed the recommendation, the solution for the recommendation is simply applied to the resource and it's finished. If the recommendation is applied to an external resource, for example, to manage the EKS cluster, then the solution is most of the time the possibility to download a script which is already parameterized to run in that specific environment. So the only thing to do is to take that script and to run it in that environment where the component is hosted, and this will fix that specific recommendation. And finally, this symbol here means that the recommendation is still in preview mode. Okay, so let's see some of those recommendations. Let's see, for example, recommendation applied to the namespaces. Sorry, namespace. Okay, so let's take, for example, this one. Containers sharing sensitive host namespaces should be avoided. This is the page containing the detail of the recommendation. It's interesting to see that we have the refreshness interval. It's important because if we fix the recommendation, we know how much time we have to wait in order to see the recommendation updated in Defender for Containers. We have also the list of the possible tactics that are considered for that specific recommendation with reference to the metrics for Kubernetes, the attack metrics for Kubernetes. We see description of the recommendation. We see the related recommendations. In this case, those recommendations are listed as related as a prerequisite. So without those recommendations, we cannot have this recommendation applied. And important, we have the remediation steps. In this case, there is no fixed button, so we do not have something which is available to download and to apply the solution, but we have quite a detailed description of what we have to do in order to fix this issue. And just specifically for that recommendation, we see that the host process ID and host IPC have to be set to false in the pod spec, so in the YAML for the pod. I see that in my lab, I have all my clusters which are affected, unhealthy for that recommendation. Why? Because basically all my environments contain a specific pod which is part of the Kubernetes GOT project, and this pod is the system monitor deployment pod. So this one is the one affected by this specific issue. Let's see, because I have here the YAML, that specific solution. Here we are, system monitor. And yes, if I go in the deployment part of the YAML, I see that in the spec, I have the host PID and the host IPC set to true instead of false. So it's correct that Defender for Clouds shows me those clusters as affected because they have this this component, this pod deployed there. Let me show you one additional detail. This recommendation right now is configured in deny mode. So we can expect that no resources can be created if they do not respect the details related to this recommendation. Of course, I can change it back to audit mode if I want. Okay, let's see what happens when I try to create a new resource in the cluster which does not respect that specific recommendation which was set in deny mode. So here I've created the copy of the deployment YAML for the system monitor solution in the Kubernetes GOT project. In that copy, I just extracted the pod definition. And of course, I kept the two settings which are not should not be allowed in my cluster. So host IPC and host PID set to true. Let's see what happens now. I just run that specific YAML through kubectl in my cluster, and my expectation is that it's blocked, and that's exactly what happens. We see that the request was denied and was blocked by the admission by gatekeeper. And the message is just that sharing the host namespace is not allowed. So exactly what we have set in the policy. Okay, let's move to two different and very important recommendations which are related to vulnerabilities. First one, here we are. Container registry images should have vulnerability findings resolved. This recommendations is running is related to vulnerabilities in images stored in Azure Container Container Registry. I have one Azure Container Registry, and where I have 12 images, and all the 12 images are vulnerable, as we see. Here we have the evidence of the severity of those vulnerabilities. The details are here. I can select, for example, one of those vulnerabilities. I see the CVE or the CVEs, if more than one, that are related to this vulnerability. Very important, very interesting. I get directly the script, the link to the script that fixes that vulnerability. So very useful in order to solve the vulnerability. Here I have all the affected resources. So I can see that this vulnerability is in a bunch of in 8 of the 12 images. I can select one of those images. In this case, I get all the vulnerabilities available in that specific image. So this is for the images in ACR, in Azure Container Registry. But I have also this recommendation here: running container images should have vulnerability findings resolved. In this case, this recommendation refers to containers running in AKS and running images taken from Azure Container Registry, images which have vulnerability. Just as an example, let's pick one of those vulnerabilities. I see that this vulnerability, again, I get all the details, I get the CVE or CVEs, I get the script for solving the vulnerability, and I get, most important, the image. So in this case, once again, it's part of the Kubernetes GOT project. It's the health check image. So I know that I have to fix, for example, this vulnerability in that specific image in order to avoid having it running in my cluster, in my AKS clusters. It's at this point, it's worth to notice that today there is no way to block a vulnerable image to be deployed and to be run in a Kubernetes cluster, but this will be quite soon available through this Azure policy. Today, it's already available in private preview. Kubernetes clusters should gate deployment of vulnerable images. So when this will be available already in public preview, which is quite soon, we will be able to completely block the deployment of vulnerable images. Okay, so those are the recommendations. Quite interesting part. Now, let's switch to the security alerts. As I said, I did a lot of exercise. Let me pick all the possible severities. And again, let me choose the resource type in order to see only the elements related to Kubernetes. So Kubernetes here. Okay. I did a lot of simulations in my lab thanks to the vulnerabilities in the Azure GOT project. A really helpful project to make this kind of test. Some of those most of those alerts are related to my test, but not all of those. For example, here I see that I get some access to my Kubernetes API, which have been done by a Tor node. So we see also this kind of detections, which are somehow related also to the threat intelligence of Microsoft. Now let's go to check some of the vulnerabilities which have, some of the alerts which have been raised because of my tests. Let's see, for example, this one, suspicious request to Kubernetes API. Yes, I did it. I make this test in one of my pods. I was able to make a call to the Kubernetes API specifically to read the secrets in a specific namespace. And I did this test in that specific container running the the Younger check image of the Kubernetes GOT project. Why this alert was raised? Because it's quite uncommon that a container makes a call to the Kubernetes API. It can be intentional, but it could be also the evidence of kind of an attack occurring to my infrastructure, and probably leveraging some of the specific misconfigurations in terms of security of my resources. Let's see some other of those alerts. Detected suspicious use of user add commands. Again, this was raised because this action was done within, so the action was a user add command, and I did it from within a container. So that's why it was raised as an alert. Again, here I have all the details. As you can see, I can open each of those tabs and I get really all the details related to the alert, so I can get full context of what was detected. And I have also the possibility to move to the take action page tab in this page, where I get evidences on how to mitigate the specific threat which was detected, and also how to prevent. I have also those advices on how to prevent future occurrence of this threat Basically, this part refers to possible existing recommendations. Okay, let's go and see some other possible recommendations which could be interesting. Access to kubeconfig file detected. Once again, here the point was that I was accessing the kubeconfig file from within a running container. So that's the test that I did. That's why it was raised as a possible alert. Those kind of vulnerabilities, privileged container detected, are different because they were this kind of alerts. Sorry, they were raised at the moment when I deployed specific containers which had this issue. So what is the issue? The issue is basically that they are running in a privileged mode. Let's see. Here we are, for example, the image. The container image is the lcheck one of the Kubernetes GOT. Let's see the definition of that specific. Here we have in the health check part of the Kubernetes GOT project, and we can see that yes, security context privileged is equal to true. So that's exact. That it's correct that the alert was raised. In this case, it was raised in the GKE cluster, but I had exactly the same for other clusters in my environment. Again, I can show you, really, there is a lot of fun you can have by exploiting all the security misconfigurations and vulnerabilities available in the Kubernetes GOT project, and to see how Defender for containers detect these. Just as another example, SSH server is running inside the container. This was very simple. I just took one of, I even did not took Kubernetes GOT image. In this case, I took one from the available repositories, public repositories with hosting in the SSH server. So specifically, yeah, I took this one from Docker.io, and it was raised as an alert. What I can show you more is just, for example, a new high privilege role detected, or container deployed in the kube system namespace, which is also something which it's not absolutely not recommended. In this case, I created this container yeah, I deployed it in the host in the kube system namespace. Okay, so this is just an overview of what you can, the kind of detection that you can have. Nice also this one, interacting directly with the services running in the worker node from the pod running in the cluster. So in this case, I was just stopping the timer service. Okay, this is just an overview of the security alert, the kind of detection that you can have with Defender for containers. Very important is the fact that you can have the full list of alerts and the recommendation in the Microsoft Defender for Containers docs pages. So if you want to have a detailed overview of what can be detected, please go there. And this page is quite often updated because the product has quite a fast evolution with the new detections available from time to time. I show you one more component of the solution, which is the newly deployed container security workbook. This is basically a dashboard which shows the same things that we have seen in the previous part of the demo, but it's in an aggregated view. As you saw, I was showing you generic recommendations for my Kubernetes cluster, and I needed to filter out the recommendations related to Kubernetes resources. I was showing you the vulnerabilities in ACR, and I needed to specifically open to a specific recommendation. I showed you how to see the vulnerabilities in running containers in AKS, and I needed to open a specific recommendation. I showed you the security alert. In this case, I filtered all the alerts related only to Kubernetes resources. So I showed you everything, but I needed to filter out things related to Kubernetes. Sometimes you want to go directly and to have a look just to what is related to Kubernetes. So you do not want to concentrate on generic threats and generic vulnerabilities or recommendation in all your resources, but you want just to deep down to have an overview of what is related to Kubernetes, to your Kubernetes clusters. So this is why we have this new nice workbook. The overview page gives statistical information and graphical representation of those details. You see, for example, the kind of the severity of the different alerts, the MITRE tactics to which they relate, the vulnerabilities in the containers registry, in the running containers images, and so on. So you can have all this kind of statistical information. Here you see the vulnerabilities in the Azure Container Registry. I have just one container registry, so I can select this and I can drill down. For example, I see that the 10 high and 1 medium vulnerability, which are in the system monitor image, which was deployed in the Azure Container Registry. Again, we are talking about the Kubernetes GOT project, and so on. So I can drill down in this way. The same is for vulnerability in the Kubernetes runtime. So in the running containers, I have just one AKS cluster, so I can select it and I get all the possible vulnerabilities. Just as an example, let's take this one, and again, I can drill down and see that it's related to the health check image, which is running in my AKS cluster. More in detail, I can see the alerts in this page. I can filter for all the alert of all the severities, and I get what we saw earlier in the demo. So all the alerts which are related to Kubernetes resources. Okay. Finally, I get the recommendations, which in this case are grouped in as a data plane recommendation and control plan recommendations. For example, I can open it and I get the link directly to the recommendation for that specific resource. Okay, so I hope that what I showed you in the demo was useful to have a basic understanding on how Defender for Containers works and have also an idea of the capabilities in terms of misconfiguration and vulnerabilities and threat detections that this product offers. I invite you to monitor the evolution of the product because it has a nice roadmap with a lot of planned new capabilities which are coming soon. So what I showed you here is updated on August 2022. So you can expect new detections and new capabilities quite soon. So thanks a lot for your attention and goodbye.